Hello, this is Dr. Hanaa Assil, and this is paper 4 of November 2017. This is version 2. This is in the IGCSE Cambridge exam. So let's take a look at the first question. It says, dust particles in the air move around in a random way. What term describes the random movement of the dust particles? Now, when particles move around randomly, this movement is called Brownian motion. But if you haven't heard this, that's okay because it was in the syllabus previously, now it is not. So just know that the answer to this question is the random movement is called Brownian motion. Identify the particles in the air which cause the random movement of the dust particles. What is moving in the air? Which particles are moving in the air? You should realize that the air has nitrogen molecules and oxygen molecules. So these are the molecules that would be moving around. Explain why the dust particles move in this way. Why are they moving around randomly? Remember that molecules in air move randomly. They collide with each other and with the dust particles, causing these dust particles to move around. Then he says when chlorine gas is put into a gas jar, it spreads out to fill the gas jar. When bromine is put into a gas jar, it also spreads out to fill the gas jar. The process takes longer for bromine than for chlorine. What term describes the way that the particles spread out? We said when particles spread out from area of high concentration to area of low concentration, this process is diffusion. Use data from the periodic table to explain why bromine gas takes longer to fill a gas jar than chlorine gas. You should know what factors affect the rate of diffusion. Remember that. If particles are diffusing, well, it mainly depends on their molecular mass. So if I look at the periodic table, I will find that the molecular mass of bromine, 1 Br is 80, but we're talking about bromine molecules. So that's 80 times 2. So the molecule of bromine has a molecular mass of 160, while the molecule of chlorine has a molecular mass of 71. And that means bromine molecules are heavier, higher molecular mass. Anything that has higher molecular mass would diffuse slower. Explain why increasing the temperature increases the rate at which the gas particles spread out. Of course, if we increase the temperature, then the particles have more kinetic energy, and that makes them move faster. Okay? Complete the table to show the electronic structure of the atoms and ions. Well, let's see. He already did fluorine for me, and I know that if I look at the periodic table, you should realize that fluorine has two numbers. The smaller one, that's the atomic number or the proton number, that is 9. And that is the same as the number of electrons. While the bigger number, which is 19, this is what we refer to as mass number, and it's actually the number of protons plus neutrons. So when we're trying to distribute the electrons, when we're trying to write the electronic structure, we look at the smaller number, the atomic number. The atomic number here is 9, so we're distributing 9 electrons. You should know that the first energy level can take only 2 electrons, so we put the rest into the next energy level. What about if we're looking at silicon? Well, if you look at the periodic table, the atomic number or the small number or the proton number of silicon is 14. And that means silicon has 14 electrons. Now, how are we going to distribute 14 electrons? You should realize that the first energy level takes 2. The next energy level can take up to 8, but I still have 4 more, so I put them into the third energy level. What about calcium 2+? Well, if I look at the periodic table, calcium has an atomic number of 20. And that means it has 20 protons and originally 20 electrons. But here he's saying this is calcium 2+. 2+ means it has lost 2 of its 20 electrons. And that means it has only 18 electrons now. And that means it is 288. N3-. Well, let's look at N. Nitrogen has atomic number 7. So originally it has 7 protons and 7 electrons. But when we say 3-, what does that mean? It means that the nitrogen atom gained 3 electrons. So instead of having 7, it now has 10. Now, how are we going to distribute 10? 2 and 8. Predict the formula of the compound formed between calcium ions and nitride ions. Well, we said the number of charges is the same as the valency. So if I say Ca2+, that means Ca has a valency of 2. N3-, that means I have a valency of 3. And we said when we write the formula, we put the valency of one under the other. So if I'm writing calcium nitride, the calcium valency 2, I put the 2 under nitrogen. The nitrogen valency 3, I put the 3 under the calcium. So this is the formula for this compound. Draw a dot and cross diagram to show the electron arrangements in the 2 ions present in lithium chloride. So I want to draw dot and cross diagram for lithium chloride. The first thing you're going to ask yourself, is this ionic or covalent? Well, when you look at the periodic table, you can see that lithium is a metal in group 1. Chlorine is a non-metal in group 7. When we have a metal with a non-metal, this is ionic. Ionic means the metal will lose electrons and become positive. The non-metal will gain electrons and become negative. So the lithium already has 2,1. So it is in group 1. It is going to lose that 1 electron. So that means it will have an extra positive charge. Now the chlorine already has 7 of its own. It's in group 7, so it has 7 electrons in its outer shell. And it's going to gain 1 that we got from the lithium, and that means it has an extra negative charge. Do not forget to write the charges. So the lithium loses its outermost electron and becomes positive. The chlorine gains an electron and becomes negative. Sulfur dichloride is a covalent compound. It has the structure of this. Draw a dot and cross diagram to show the electron arrangement in a molecule of sulfur dichloride. So, sulfur and chlorine are both non-metals. And when we have 2 non-metals, that means this is covalent. And since it is covalent, it is going to share. I'm not going to have any positives or negatives. They're going to share electrons. So, chlorine has 7. It needs how many? It needs 1 more. So, it's going to share 1 pair of electrons with the sulfur. But the sulfur is in group 6. It has 6 electrons. So, it will need 2 more. But each chlorine can give me only 1. And that's why I need 2 chlorines to share 2 pairs of electrons with the sulfur. And don't forget that I already have the rest of the electrons on the chlorine and the rest of the electrons on the sulfur. The chlorine has 7. It used only 1 for sharing, so don't forget the 6 electrons left around it. The sulfur is going to share 1 with each chlorine. That means it still has the rest of the 6, so it still has 4 electrons that you need to put in. In terms of attractive forces, explain why lithium chloride has a higher melting point than sulfur chloride or sulfur dichloride. Okay, looking at lithium chloride, we said it is ionic. What does that mean? It means you should know that ionic compounds, if I'm talking about their structure, It is a giant three-dimensional crystal lattice with alternating positive and negative ions. That means I don't just have one lithium with one chlorine. No, I have a giant molecule with many, many positives and negative ions. And that means lithium chloride has strong attraction forces between the positive and negative ions, or between the oppositely charged ions, in a giant crystal lattice. So I don't just have a few of them. And all of this needs a lot of energy to be broken. But if I look at sulfur dichloride, we said this is covalent. Covalent molecules, simple molecular molecules, only have weak attraction forces between them. So this has weak attraction forces between molecules that need a small amount of energy to be broken. That is why its melting point would be lower than lithium chloride. Suggest the identity of a covalent compound with a higher melting point than lithium chloride. We know that ionic compounds have high melting point. But which covalent compound would have higher? Remember that we have giant covalent molecules. The giant covalent molecules that we talked about were diamond, graphite, and remember that diamond and graphite are only made of carbon. So these are elements. Remember, diamond and graphite are elements. I want a covalent compound that is giant with higher melting point than ionic compounds. That would be silicon dioxide or silicon 4 oxide. Remember that silicon dioxide has the structure similar to that of diamond. But diamond, all the atoms are carbon, so it's an element, so I cannot mention it here. Silicon dioxide is made up of silicon and oxygen, and remember we said each silicon is covalently bonded to 4 oxygens, and each oxygen is covalently bonded to 2 silicons. So this is a covalent compound with a giant structure, so it would have a very, very high melting point. Question 3 says the chemical equation for the complete combustion of ethanol is this. The energy released when 1 mole of ethanol undergoes complete combustion is this. Remember, he's saying energy released in complete combustion is this. Put a part of the energy level diagram has been shown. Complete the energy level diagram to show, first of all, the products and the overall energy change. This is what kind of reaction, exothermic or endothermic? Well, you should know that. First of all, combustion, burning is always exothermic, and he says energy released. So that means it gives out heat, and that means it is exothermic, and that means where are the products? It means the reactants have lost energy, and that means the products will have lower energy than the reactants. So remember that for an exothermic reaction, the products have lower energy because exothermic means the reactants gave out heat. So they lost some of the heat that they had, and that means the products will have lower energy. And then he's saying, where is the overall energy change? Well, going from there to the products, the delta H, or the energy change, is the difference in energy between the reactants and the products. So you need an arrow going down from reactants to products, and he's saying the energy released is 1280, and that means delta H is minus 1280. Then he's saying, what is X? That arrow pointing up, it represents what? You should know that it represents energy of activation, or we call it activation energy. The chemical equation for the complete combustion of methanol is shown, and he writes it out showing you all the bonds. And then he's saying use the bond energies in the table to determine the energy change for the complete combustion of 1 mole of methanol. If you look at the equation, he has 2 moles of methanol. So if I'm going to calculate the delta H for this reaction, I will have to divide it by 2 in order to get the delta H for 1 mole. So let's calculate it as it is for now. We're saying energy needed to break the bonds. Which bonds are being broken? They're the bonds in the reactant. So what do we have in the reactants? We have 2 methanol. Each methanol has what? Has 3 CHs. So I'm going to multiply by 2. I have 3 CHs. Each one from the table is 410. Plus I have a CO bond that he says it's 360, plus an OH bond that is 460, so that is the methanol, the 2 methanol molecules. Plus I have 3 oxygen molecules. Each of them needs 500, so that would be 3 times 500. The total of this is 5600 kilojoules. Now, energy released when bonds are formed, remember we said bonds formation in the products is exothermic. So when these bonds are formed, they give out energy. Now they will give out how much energy? Well, we have 2 of the CO2 and each of the CO2 has 2 CO bonds. So I have 2 times 2 of the CO bonds. The CO bond is 805. Plus I have 4 water molecules, but each water molecule has 2 OH bonds. So that's 4 times 2 times the OH bond, which is 460. This gives me a total of 6900 kilojoules. Now, how do we get delta H? We said the delta H is the reactants minus the products. And this gives me a certain number, and remember all of this is an exothermic, so it does come out to be a negative value. But remember that this is for 2 moles of methanol, so I still have to divide that number by 2 in order to get the delta H per mole, or for 1 mole. Dodecane is an alkane containing 12 carbon atoms. Ethanol can be manufactured from dodecane in a 2-stage process. In stage 1, each molecule of dodecane is converted into 3 molecules of ethene and 1 molecule of another hydrocarbon. Name this process when I break something that has 12 carbon atoms into smaller molecules. This is called cracking. Do you remember the conditions for cracking? If you were asking for the conditions of cracking, you should remember that cracking needs catalyst, aluminum oxide catalyst, temperature 400 to 700 degrees Celsius. So this is a process called cracking, where we break down long chain molecules into shorter chains. Then he's saying write a chemical equation for the reaction. How will you write the formula? Of course, a chemical equation means a balanced symbol equation. What do you think is the formula of dodecane? He's telling me it's an alkane. Do you know the general formula of alkanes? General formula for alkanes is CnH2n plus 2. And he's saying it's alkane containing 12 carbon atoms. So if it is C12, it is H what? You should realize 2n plus 2. So if it is C12, the H will be 2 times 12, which is 24, plus 2, so that's 26. And he's giving me, it is converted into what? 3 molecules of ethene. Ethene is something that has 2 carbons. Alkene means the hydrogens are twice the carbons. So ethene is C2H4, and he's telling me I have 3 of them. And 1 molecule of something else. All you need to do is what is left. So I started with 12 carbons. Now the 3 ethenes have 2 times 3, so that is 6. So how many carbons are left? I'm left with C6. I started with 26 hydrogen. I took away 3 times 4, which is 12. So I am left with 14 hydrogen. Are we okay? Do we understand how we got the C6H14? It's just the rest of the C12H26. In stage 2, ethene reacts with steam to produce ethanol. So this is what we call hydration of ethene. When we have ethene and we add steam, this gives ethanol. So this is one of the methods of making ethanol. We call it hydration of ethene. What are the conditions for hydration of ethene? You should remember, when we add steam to ethene, what happens? We add water to it, so that gives me ethanol. The conditions are phosphoric acid catalyst, 300 degrees Celsius. These are the conditions. Please remember the certain conditions that we have that we should remember. This is one of them. When we add steam to ethene to get ethanol, I need phosphoric acid catalyst and 300 degrees Celsius. What is the type? We just said what type of reaction is this? This is an addition reaction, or you could mention that it is a hydration, because hydration means you're adding water. So you can either refer to it as hydration, or in general, alkenes do addition reactions. So just how to test the purity of the ethanol produced? Well, how do we test the purity of course, you know that ethanol is a liquid. So how do we test the purity of any liquid? Well, to know if a liquid is pure or not, we determine its boiling point compared to the actual value. Remember that if it is pure, it should have a sharp melting point or boiling point. Of course, the melting point if we're talking about a solid, the boiling point if we're talking about a liquid. A pure liquid should have a specific boiling point, and it shouldn't be lower than the actual value in the data book. Ethanol can also be manufactured by the fermentation of glucose. State 2 conditions needed for fermentation of glucose. So we said ethanol can be made either by hydration of ethene, that was what we were just talking about, which requires phosphoric acid catalyst and 300 degrees Celsius, or we can do it by fermentation, and fermentation means I add yeast to the glucose at about 37 degrees Celsius. If you want another condition, you should remember that this has to be done in absence of oxygen. Complete the chemical equation for the fermentation of glucose. So when we do fermentation of glucose, the glucose changes into what? You should know that it changes into ethanol plus carbon dioxide, and then you need to balance, and this is the balancing for the equation. One disadvantage of fermentation is that the maximum concentration of ethanol produced is about 15%. So just why the concentration of ethanol produced by fermentation does not exceed 15%. Remember, when we're doing fermentation, we have yeast in water and glucose, and we're trying to change the glucose into ethanol, but the problem is, once we have a lot of ethanol in the solution, this starts to kill the yeast. So the presence of ethanol in the solution kills the yeast, so no more reaction can happen, or the reaction becomes very slow. Give one other disadvantage of making ethanol by fermentation. He wants a disadvantage. Remember when we talked about these processes, they have advantages and they have disadvantages. What was the disadvantage of fermentation? That the reaction is slow. Give one advantage other than cost of manufacturing ethanol by fermentation. Why is it good to make ethanol by fermentation? Well, you should know that the glucose we get from sugarcane, and sugarcane is a renewable resource, so the advantage is this is obtained from renewable resources. So just the name of a process to obtain ethanol from a mixture of ethanol and water. Remember that at the end of the reaction, I have yeast and ethanol and water. We get rid of the yeast by filtration, but then I'm left with ethanol and water. In order to get ethanol from a mixture of liquids, we do fractional distillation. Ethene 1,2-diol has the following structure. Write the empirical formula of ethane 1,2-diol. First of all, what do we mean by empirical formula? You should remember that empirical formula is the formula showing the simplest ratio between the atoms. So, if I were to write the molecular formula of this, molecular formula means all the carbons, hydrogens, and oxygens. How many carbons do I have? I have 2 carbons, 6 hydrogens, 2 oxygens. So the molecular formula is C2H6O2. What would be the empirical? The empirical is if I simplify all of this. So I divide by the smallest. So the empirical formula of this compound would be CH3O if I divide through by 2. Do we understand the difference between molecular and empirical? Molecular shows the actual number of carbons and hydrogens and oxygens. Empirical shows the simplest ratio between the atoms. Ethene 1,2-diol can undergo condensation polymerization, but cannot undergo addition. Explain why this cannot undergo addition. Of course, what kind of molecules can undergo addition? It's the ones that have C-double-bond-C or alkenes. Remember that addition, polymerization, I have to start with alkenes. So this is not an alkene. There is no C-double-bond-C, so this cannot do addition polymerization. Ethane 1,2-diol undergoes condensation polymerization with another molecule which he calls Y. And you can see that ethane 1,2-diol has OH on both ends. Molecule Y has acid group on both ends, and we said we can join these kinds of monomers to make a polymer, and that is called condensation polymerization. Now, draw the condensation polymer formed between these two molecules. How do we draw condensation polymers? We remove OH from the acid, H from the alcohol. And then I'm going to remove H on the left also because I'm going to join it to another acid on the other end. I'm going to remove the OH on the right because I'm going to join it to another molecule on the right. And that means my polymer will look something like this. O box O, C double bond O, box C double bond O. And remember that when we have acid with alcohol, what comes out is called an ester linkage. So this ester, C double bond O, O is an ester linkage, and the type of polymer is polyester. Are we okay with all of this? A student sets up the following electrolysis experiment. First of all, define the term electrolysis. What does electrolysis mean? Electrolysis means breakdown of an ionic compound using an electric current. The student observes bubbles of colorless gas forming at each electrode. Name the main gas produced at the positive electrode. Well, when I do this, I look. What is he doing? He's doing electrolysis of what? Dilute aqueous sodium chloride. So that means what kind of ions do I have? I have the ions from sodium chloride, which are Na plus Cl minus, and I have the ions from water. This is aqueous, so I have H plus and OH minus. The positives go to the negative electrode, the negative ions go to the positive electrode. He's asking, name the gas produced at the positive. Well, I have a choice between chloride ions and hydroxide ions. And we said when we have a choice between chloride and hydroxide, the one present in larger amounts is the one that will react. So which one is present in larger amounts if I'm talking about dilute solution? What does dilute solution mean? Dilute solution means I have a lot of water. And that means I have a lot of OH minus. So it is the OH minus that will react. And when OH minus reacts, it gives oxygen gas. So the gas formed at the positive is oxygen. Describe a test for this gas. What is the test for oxygen gas? Remember, to test for oxygen, insert a glowing splint. It relights. This is test for oxygen. Please revise all the tests and do not mix up between them. Write the ionic half equation for the reaction taking place at the negative. Where is the negative? The negative, we have Na plus and H plus at the negative electrode. Now, that means I have a choice between Na plus and H plus. And we said when we have a choice between Na plus and H plus, the one that is lower in the reactivity series is the one that reacts. So between sodium and hydrogen, which one is lower in the reactivity series? Hydrogen, then that's the one that will react. And when the H plus reacts, it takes electrons. So the H plus will take electrons to form hydrogen, and we need to balance. I have 2 hydrogen atoms after the arrow, so I need 2 hydrogens before the arrow. That means I have 2 positives. I balance it with 2 negatives on the electrons. Charge is transferred during electrolysis. Name the type of particles responsible for the transfer of charge in the wires and the electrolyte. Now, if we look at electrolysis setup here, what moves through the wires to conduct electricity is electrons. And what moves through the solution, through the electrolyte to conduct electricity is the positive and negative ions. So always remember that in any electrolysis reaction or experiment, the electrons move in the wire towards the positive end of the battery and away from the negative end of the battery. The electrolyte, we have movement of positive and negative ions. The positive ions go to the negative electrode. The negative ions go to the positive electrode. The student replaces the dilute aqueous sodium chloride with concentrated. So instead of having dilute, now we have concentrated. What is the difference? Remember that concentrated means I have a lot of chloride ions. And we said when choosing what happens at the positive, is it the chloride that will react or the OH minus? We said the one present in larger amounts. So if I have concentrated aqueous sodium chloride, that means I have more chloride ions, and that means it forms chlorine. But what am I going to observe? If it gives out chlorine, then what I see is bubbles of green gas at the anode. Don't say chlorine gas is formed. He's saying, what does the student observe? What do you see? I'm going to form chlorine gas. That means I'm going to see what? Bubbles of green gas at the anode. Besides, if you have concentrated solution, that means you have more and more ions moving around, and that means more electric current will pass through, and the bulb, can you see the bulb? The lamp or the bulb will be brighter. The student has a small piece of impure copper. The main impurities in the copper are small quantities of silver and zinc. The student uses electrolysis to extract pure copper. So, of course, this is a method of purification of copper. Now, complete the labels of the student's electrolysis experiment. When we do purification of copper, what is my positive electrode and what is my negative electrode? Remember, I'm trying to purify copper. Copper ions are positive, so they should go to the negative. So that means that my positive is the impure copper. My negative is the pure copper. Remember, we said we put a small thin piece of pure copper as the cathode so that the Cu2 plus will go there, react, and deposit as copper metal, and that means my cathode will become thicker and thicker and my anode will become smaller and smaller. What is the electrolyte? We know that the electrolyte should be a solution of copper something. So I want something that is soluble. So I can say aqueous copper sulfate because I know that copper sulfate is soluble. If you're not sure of something, whether it's soluble or not, then you should choose the nitrate because we said any nitrate is soluble. But we know that copper sulfate is soluble. Use your knowledge of the reactivity series to suggest what happens to the silver and zinc impurities. Remember that we're trying to decide which one with respect to the copper will react. So if I have silver impurities, where is the silver? The silver is below the copper, and that means it is less reactive than the copper. So the silver metal is the one that will react at the electrode and it will form at the bottom of the cell. But if we're looking at the zinc, where is the zinc with respect to the copper? The zinc is more reactive than copper. So the zinc ions will remain in solution and it is the copper that will deposit on the cathode. Some chemical reactions are reversible. Aqueous potassium chromate is yellow. Aqueous potassium dichromate is orange. The two compounds interconvert when the pH of the solution changes. So I am changing between a yellow solution and an orange solution. Solution Y is a mixture of potassium chromate and potassium dichromate in equilibrium. So solution Y is this whole equation going back and forth. Now explain in terms of the position of equilibrium what you would see if sulfuric acid was added to the solution. Where is sulfuric acid? So this is on the left side of the arrow, and we're saying if we're adding sulfuric acid, remember that this equation originally is at equilibrium. Now if we add any of the reactants, then it will try to go so that it will use up what we're adding. So if we add one of the reactants, the point of equilibrium will shift to the right. Now when it shifts to the right, that means it goes forward. When it goes forward, that means it will form more of the orange solution. So adding more acid causes the equilibrium to shift to the right, so the solution becomes orange. Do we understand this? Adding any of the reactants, the equilibrium shifts to the right. Explain in terms of the position of equilibrium what you would see if sodium hydroxide was added. Now, if we add sodium hydroxide, how will it affect this reaction? You can see that if I add sodium hydroxide, it will react with the acid. So it is actually as if I am removing some of the acid, and that means the point of equilibrium will shift to the left to produce more acid because it wants to go back to what it was. So the sodium hydroxide neutralizes the acid. This causes the equilibrium to shift to the left to produce more acid, and that means the solution will become yellow. Hydrogen can be manufactured using a reversible reaction between methane and steam. At 900 degrees Celsius in presence of a nickel catalyst, the yield of hydrogen is 70%. What volume of hydrogen is produced from 100 centimeter cubed of methane under these conditions? So he's saying we're starting with 100 centimeter cubed of methane. So the first thing I can do is get the number of moles of methane. Number of moles of a gas is volume over 24. Remember, we divide the volume by 1,000. So this is 0.1 over 24. This gives me the number of moles of methane. And then that means from the equation, looking at the equation, 1 mole of methane gives 3 moles of hydrogen. So that means that the number of moles of hydrogen is 3 times the number of moles of methane. So that gives me number of moles of hydrogen. Now that means that the volume of hydrogen that would be obtained, we know that volume is number of moles times 24. So that, and the answer comes out in decimeter cube. That means I will get 300 centimeter cube. But that is if the reaction goes to completion. He's telling me that the yield of hydrogen is only 70%. So if I say we're supposed to get 300, but actually the yield is 70%, so 70% of that is 210 centimeter cubed, and that means that is the actual volume of hydrogen that we will end up with. Okay, under different conditions, different yields of hydrogen are obtained. If the pressure is increased, the yield of hydrogen becomes less than what we got originally. Now, why is that? If we look at the equation and we're going to increase the pressure, increasing the pressure causes the reversible reaction to go to which side? You should know that increasing the pressure, reaction goes to the side with less number of moles. So where do we have less number of moles? Forward or backward? If I go forward to the right, I make 1 mole of CO and 3 moles of hydrogen, that is 4 moles. If I go to the left, then we make 1 mole of methane and 1 mole of water, that is 2 moles. And we said, increasing the pressure, the reaction goes to the side with less number of moles, so the equilibrium shifts to the left to give less number of moles, and that means I will get less of the hydrogen product. If the temperature is decreased, the yield of hydrogen decreases. What does this information indicate about the reaction between methane and steam? Now, he's lowering the temperature. You should realize that if we lower the temperature, it goes to the side that is exo. Lower temperature goes exo. Now, he lowered the temperature and he got less hydrogen. That means he went backwards. And that means the backward is the exo, and that means the forward is endothermic. Are we following? If we increase pressure, it goes to the side with less number of moles. If we decrease temperature, it goes to the side that is exo, or the opposite. Why is a catalyst used in this reaction? Of course, a catalyst is used in any reaction to increase the rate of the reaction. Okay, that's the end of this paper. I hope this was useful. Please revise again anything that you were not able to answer, and please share this with other students so that they can benefit. Thank you for listening.